Hi, welcome to this session on Mathematics, Chapter 2 on Polynomials. For Class 10 or Grade 10, we are doing exercise 2.2, question number 1. Question number 1 states, find the zeros of the following quadratic polynomials and verify the relationship between zeros and the coefficients. Answer 1, part 1, x square minus 2x minus 8. This can be written as x square minus 4x plus 2x minus 8. And once simplified, it gives us this polynomial is equal to x plus 2 multiplied by x minus 4. And this implies that either x plus 2 is equal to 0 or x minus 4 is equal to 0. And both these imply that either x is equal to minus 2 or x is equal to 4. Hence, we can say that the zeros of the given polynomial are minus 2 and 4. So now let's verify that the relationship between the coefficient is as what we know. So first let's see the sum of the zeros. We have already found the zeros as minus 2 and 4. So the sum will be equal to 2, and which indeed is equal to minus b by a, because the b in the given polynomial is minus 2 and minus b by a is equal to minus of minus 2 by 1, which is equal to 2. Hence we have verified this relationship. Similarly, we see that the product of the zeros which we have found just now is equal to minus 2 into 4, and this gives us minus 8, and this minus 8 is indeed equal to c divided by a, because c divided by a is equal to minus 8 by 1, that is minus 8. Hence we have verified the relationship between coefficients and the zeros. Next, answer 1 part 2, 4s square minus 4s plus 1. This can be written as 4s square minus 2s plus 1, which gives us, or which is equal to 2s minus 1 multiplied by 2s minus 1, which implies s is equal to 1 by 2. And again, because there are this term 2s minus 1 is twice, so we can say that we have two zeros for this polynomial, and both of those zeros are equal. So we have first zero as 1 by 2, the second zero is also 1 by 2. So we have found the two zeros of the given polynomial. Now let's start the verification process. The sum of the zeros is 1 by 2 plus 1 by 2 is equal to 1. This is what we have gotten because we found the two zeros to be 1 by 2 and 1 by 2. Now this sum, or this 1, is indeed equal to minus b by a, because minus b by a is equal to minus of minus 4 divided by 4, which is equal to 1. So we have verified this relationship. Similarly, the product of the zeros will be 1 by 2 multiplied by 1 by 2, which is equal to 1 by 4, and which will be equal to c by a, and which is equal to 1 divided by 4, which is equal to the constant term divided by the coefficient of x square. Hence, we have verified the relationship between 0 and the coefficients. Answer 1 part 3, 6x square minus 7x minus 3. This can be written as 6x square minus 9x plus 2x minus 3, which will be equal to 3x plus 1 times 2x minus 3. Hence, we can say that either the x is equal to minus 1 by 3 or x is equal to 3 by 2. That is, the zeros of the given polynomial are minus 1 by 3 and 3 by 2. Now let's verify. So first see what's the sum of the zeros that we have found. This 0 will be equal to minus 1 by 3 plus 3 by 2, which is equal to 7 by 6. And this sum is indeed equal to minus b by a, because b is minus 7. So minus b by a will be 7 by 6, and that 7 by 6 is equal to the 7 by 6 that we found by summing up the zeros that we found. Similarly, product of the zeros will be minus 1 by 3 multiplied by 3 by 2, which will be equal to minus 1 by 2. And this minus 1 by 2 is equal to c by a, because in the given polynomial c is minus 3. So we have c by a is equal to minus 3 by 6, which is equal to minus 1 by 2, and which is equal to the same value that we found by multiplying the zeros that we had found here. So hence we can say that we have verified the relationship between coefficients and the zeros as well. Now let's go to the answer 1 part 4. We are given 4u square plus 8u, which is equal to 4u times u plus 2, which implies that either u is equal to minus 2 or u is equal to 0. That is, we have found the zeros of the given polynomial as 0 and minus 2. So now let's start the verification process. So the sum of the zeros which we just found out will be 0 plus minus 2, which will be equal to minus 2. And this sum is indeed equal to minus b by a. That is, in our case, in the polynomial we are given the value of b is 8 and minus b will be minus 8, a will be 4. So this minus b by a will be equal to minus 2, and that indeed is equal to the sum that we found by adding up the zeros that we calculated. So this relationship has been verified. Similarly, the product of the zeros will be 0 multiplied by minus 2 is equal to 0, which is equal to c by a, which is equal to 0 by 4, because c in our case is 0, hence it is equal to 0, and we have verified the relationship between coefficient and the zeros. Let's now talk about answer 1 part 5. We are given t square minus 15. To find zeros of this polynomial, let's make this polynomial equal to 0. That is, t square minus 15 is equal to 0, which implies t is equal to plus or minus of square root of 15. So we get the zeros of this given polynomial as minus 15 square root or plus of square root of 15. In fact, there is another way to find the zeros of this polynomial, and let's see that another way. We note that the given polynomial is t square minus 15, which is of the form a square minus b square if b is square root of 15. That is, t square minus 15 is equal to t square minus square root of 15's square. And we know that a square minus b square is equal to a minus b multiplied by a plus b. So this entire given polynomial will be equal to t minus square root of 15 times t plus square root of 15. So comparing or trying to get the zeros, we get that t minus square root of 15 will be equal to 0, or t plus square root of 15 will be equal to 0. Then by doing this comparison, we get that the zero of the given polynomial are minus square root of 15 plus square root of 15. So we have found the zeros of the polynomial as minus 15 or plus 15. And now let's do the verification. Sum of the zeros will be minus square root of 15 plus square root of 15, which will be equal to 0. And this indeed is equal to minus b by a, because b in our case is 0, and this b by a will become 0 by 1, which is 0. The product of the zeros will be minus square root of 15 multiplied by square root of 15, which will be equal to minus 15, and which actually is equal to c divided by a, because c by a is equal to minus 15 by 1, which is equal to minus 15. Hence we have verified the relationship. Next, let's consider the answer number 1 part 6. We are given 3x square minus x minus 4, and this can be simplified to be written as x plus 1 times 3x minus 4, which implies either x plus 1 is equal to 0 or 3x minus 4 is equal to 0. And by doing this, we get the value of x as x is equal to minus 1 or x is equal to 4 divided by 3. That is, now we have found the zeros of the given polynomial as minus 1 and 4 divided by 3. So let's now do the verification. Sum of the zeros that we just found will be equal to minus 1 plus 4 by 3, which is equal to 1 divided by 3, which is equal to minus b by a. Similarly, product of the zeros will be minus 1 multiplied by 4 by 3, which is equal to minus 4 by 3, which indeed is equal to c by a.